Welcome to the Chemistry YouTube channel. Maharashtra SET 2020 question and answer with detailed explanatory answer. Chemical Science Paper 2 Part 5. Question number 51. Epoxides X and Y is given. Give the same aldehyde on BF3 etherate catalyzed rearrangement. The correct statement is in X and Y both H migrates. pH migrates both in X and Y. H migrates in X, pH migrates in Y. pH migrates in X, H migrates in Y. So what will be the, let us take the compound. Let us take compound X, and here it's O. Is having one lone pair of electron, where here the BF3 is added because BF3 is a Lewis acid. So you will get here there is one hydrogen, and this hydrogen migrates here, and it's a dotted line. So O here, BF3 here, and this bond gets weaker. This bond gets weaker, and this hydrogen here migrates. Now what you will get? pH, here one H, that is a migrated hydrogen. Here O, BF3. So this gives a product. pH is an aldehyde. You know the product will be an aldehyde. So in X, hydrogen migrates. Let us take the second compound. Now again add BF3, the same Lewis acid. Now what happens? This BF3 adds here to oxygen. Here is a lone pair, and here what happens? The pH migrates, and this bond gets weaker. This bond gets weaker, hence the pH migrates here. So you will have pH here, O, BF3. It's O, BF3. Here it is a plus. So this gives the product. This also gives an aldehyde. It's a pH. So same aldehyde. The product is same. X, hydrogen migrates. In Y, pH migrates. Hence the answer. Hence here the answer C is correct. H migrates in X, pH migrates in Y. Next question number 58. The major product formed in the following reaction is. The reactant has been given. On treating with cyclohexane, what happens? Here this reaction is a any reaction. Any reaction is a chemical reaction between alkene with an allylic hydrogen, the ene, and a compound containing multiple bond, enophile, in order to form a new sigma bond with migrating any double bond with 1 hydrogen, 1,5 hydrogen shift. Here it's a enophile, this is a ene. This double bond shift here to form a new compound. This is called any reaction. And here let us take the compound, the given compound. This hydrogen. Now what happens? This shifts here, and this shift here, and 1, 5. So 1, 2, 3, 4, 5, and 1, 5 shift to form a new sigma bond is formed by 1,5 hydrogen shift. So this reaction is a any reaction. Here the answer A is correct. This in question number 59. This compound, this reaction goes through free radical intermediate, carbanion, carbocation, and carbene. The intermediate was asked. Here you see in COOAg, this cleaves, and this Br cleaves to give COO radical. It's a free radical. Hence the intermediate is a free radical. Free radical intermediate, not carbocation, not an carbanion. And here this CO2 cleaves minus CO2. You will get a free radical here. This is stabilized by the ring, and this Br free radical, again this Br free radical reacts to give the product. Hence this reaction undergoes free radical intermediate. Question number 60. The major product following the reaction is. Let us take the reactant. Here KH, K plus and H minus. This on reflux gives this H minus, the hydride ion reacts with this OH to give O minus, and here you see, let us take this as 1, 2, 3, and here it's a 1, 2, 3, and this bond breaks, here to give, and let us number here is a 1, 2, 3, 4, 5, 6. Again here it's a 1, 2, 3, 4, 5. Here it's a K plus. Again this rearranges to give. I count like this: 1, 2, 3, 4, 5, 6. Here it's a double bond. Double bond is between 4 and 5. Again here 1, 2, 3. Here we get 1 O minus and 1 double bond here. So 4, 5, 6. And this will be the cyclized product. This on keto-enol tautomerism, double bond O, and this double bond here. So this will be the correct answer is D. Now question number 61. The major product following the reaction. The reactant indole is given. The reactant indole is given on treatment with DMF, POCl3. In presence of NaOH, what will be the product? Let us take the reactant indole. This is indole, the reactant is given in presence of DMF and POCl3. So here let us take DMF plus POCl3. Now this bond shift here. And chlorine shift here to give you a product like this. This will be the, and here this shift minus PO2Cl2 and one Cl minus will be added to give CHCl N plus Me. Now you add indole, the reactant. Now you add indole, you will get N plus here, Cl N plus Me. Again this NaOH, and treating with NaOH, what happens? You will get OH here, say Me. So double bond here. This again on rearranging gives is a keto-enol tautomerism, 3-indole aldehyde. This is the product.